Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded Module 1 and Module 2 videos. If you have not checked out, please do check out in my channel. Module 3 also have done many of the topics. This video is the last and final topic, which is signal flow graph. We have already seen block diagram reduction. In the same way, signal flow graph also will help to find the transfer function. We will see that topic in this video. I have already done till here. Till the previous video, I covered all the topics till the 7th point. Now the 8th point is signal flow graphs. Under that, construction, basic properties, signal flow graph algebra and construction of signal flow graph for control system. I'll do these all topics in this video. Signal flow graph may be regarded as a simplified version of a block diagram. Am I right? A signal flow graph means what? Is regarded as a simplified version of a block diagram. We have already seen in the previous video the block diagram reduction. I am going to do some of the block diagram reduction problems which we have done previously in the previous video. Those problems only in how to convert to signal flow graph and do the signal flow graph using signal flow graph to find the transfer function we will see in this video. So simplified version of the block diagram is nothing but what? Signal flow graph. We can simplify the block diagram into signal flow graph and find the transfer function. Mason's gain formula is especially useful in reducing large and complex system diagrams in one step without requiring step-by-step reductions. Whereas we have seen in block diagram reduction, we need step-by-step reduction. But here Mason gain formula is used for signal flow graph so that we can reduce the large and complex system diagrams in one step without requiring step-by-step reductions. Various terms used in formulation of signal flow graphs are given below. These are the different terms which we should know. That is node. Node represents a system's variable which is equal to sum of all the incoming signals at the node. Outgoing signals from that node do not affect the value of the node variable. Okay, all the incoming signals can be summed at this node. Branch is nothing but a branch is a line segment of the signal flow graph joining two nodes along which a signal travels from one node to other in direction indicated by the branch arrow, and the process gets multiplied by the gain or transmittance of the branch. Branch is nothing but, if this is a line flow graph in this way, if another block is drawn here, then based on the arrow marks, the signal will flow. This is called branch. Okay. If we are dividing one line into two lines, a signal of lines, that is nothing but branch. Input node or source. Input node is a node with only outgoing branches. It does not have any incoming branches. Input node means what? Incoming nodes, nothing but source. It does not have the it does have only the outgoing branches. Why? Because it is going inside. It is going going inside, but with only outgoing branches. If we are going in, only outgoing branches are available. It does not have any incoming branches. For example, this is the source node. There will be no incoming branches to that. Only from that node, input node, only outgoing branches will be available. Output node. Output node is node with only incoming branches. If this is the output node, this is the input node, this is the output node, then what happens? This signal looks like it is going incoming branch. Let's say it is going into the outgoing branch. Nothing but output node is node with only incoming branches. It does not have any outgoing branches will be not there for output. Only incoming branches will be there for the output node. Then mixed node. Mixed node is nothing but a mixed node is that has both incoming and outgoing branches. Path. A path is the traversal of connected branches in the direction of the branch arrows such that no node is traversed more than once. Path is nothing but from, if this is the source, this is the destination, path. It is going to, based on the branches, it is going to traverse in one direction. Connected branch in the direction of the branch arrow such that no node is traverse move. Only one time it is going to. For example, there is another. It should go once this side and once this side. No, it should not repeat more than once. Understanding? That is nothing but path. Forward path. Forward path is a path that starts at an input node and ends at an output node, and along which no node is traversed more than once, from input node to output node. Loop is nothing but a path which originates and terminates with the same node, and along which no node is traversed more than once. For example, this is a line. If it is going in this way and in this way, and see, if it is started here, again it will end here. This is one loop. Okay, understanding? This is one loop. Like this, if there are any loops, it is called as a loop. Non-touching loops, which do not possess any common node. For example, on a line, there are 2 points like this, where there is one loop here and one loop here. Then there is no common, there are non-touching loops. For example, this loop is connected to here. Then what happens? There is a common node for this loop and this loop. So these are touching loops. They are not non-touching loops. Non-touching loop means which does not touch each other and does not have a common node. It does not have a common node. Then path gain. The product of the branch gains encountered in traversing a path is called the path gain. The product of the branch gains, nothing but if there is a signal like this and arrow mark, this is 1 point, this is 1 point. If this is given, this is the path gain. Path gain. Okay. Forward path gain, the product of branch gains encountered in transferring the forward path. If there is a path, in that how many gains are there? No, those all gains product is nothing but forward path gain. Loop gain, the product of the branch gains encountered in transversing the loop. Loop also has gains. No, if you product those gains, that is nothing but loop gain. Self loop. A self loop is a loop consisting of a single branch. Self loop is nothing but it is a loop which consists only a single branch. These are the main terminologies you should know. Construction of signal flow graph. The signal flow graph of a system is constructed from its describing equations. From the describing equations, we can draw the signal flow graph. This is nothing but the construction of signal flow graph. To outline the procedure, let us consider a system described by the following set of equations. These are the set of equations. We will see how to draw the signal flow diagram from these equations. How to draw? See, x2 is equals to a1 to x1 plus a2 to x2 plus a3 to x3 plus a4 to x4 plus a5 to x5. There are total 5 nodes. By this you can understand there are 5 nodes. 5 because still it is 5. So you will put 5 dots first. Then dots or nodes. Okay. Then what is they have given us? First we will write this first equation. A1 to x1. A12 is the gain. So we will draw a line and we will mark a forward path with gain A12 and x1 at x1 point. At x2 point what it is there? Self loop, it is A22 is there. Then A3 to x3. There is A3 to x3. A3 to x3 is what? This is A3 to x3. A3 to x3. Understanding? A3 to x3. Why? Because A32 is there. It is not in the forward direction, backward. So from 3 to 2 it is going. So you will mention in the opposite direction as a feedback. A3 to x3. Then you have A4 to x4. Again feedback. From 4 to 2. A4 to x2. Then it is between A5 to x5. Between 5 and 2. A5 to A52 is nothing but from 5 to 2 you will take from the point of x5. Okay. This is what is the first equation. Second equation, x3 is equals to A23 x2. A23 x2 means what? You will mention from A2 to 3 one gain. A23 is the gain between x2 and x3 in the forward path. A34, x3. A34 is again forward path. 3 to 4, you will draw a line and a forward path, that is A34. Then there is A44 self loop, x4. You will draw a self loop like this to the A4. X4. Then you have A35, x3. A35, 3 to 5 forward path, A35 and A45, x4. From x4 to x5 there is A45. You will draw that and mention the gain above the arrow mark. Then you combine this all A, B, C, D, E and you will draw all the paths. A22, A44 loop. These all paths, this will become the signal flow. From the equations, describing equations, you can draw the signal flow graph, where x1 is the input variable and x5 is the output variable. And if you do x5 by x1, you will get the transfer function. Understanding x5 by x1, you will get the transfer function. This is how you draw the signal flow graph from the equations. Now we will see the Masson gains formula to do the transfer function. The overall gain from input to output may be obtained by Masson's gain formula. Masson's gain formula is used to find the transfer function, that is overall gain from input to output. The relationship between an input variable and output variable of a signal flow graph is given by the net gain between the input and output nodes and is known as the overall gain of the system. From the input nodes to output nodes, the overall gain will be the net gain of the input and output nodes is nothing but overall gain of the system. Masson's gain formula for the determination of the overall system gain is given by T is equals to, it's the transfer function, equals to summation K, mk, delta K, mk to how many ever nodes is there, how many ever paths or whatever is there, so many, delta K by delta, summation K, mk into delta K by delta. You know the transfer function, T is nothing but transfer function of the system. Mk is what? Forward path gain of kth forward path. How many number of forward paths are possible? Those, that is nothing but it's a gain. If there is a signal flow graph like this, another one loop like this, here this is one flow, one path, and this is one more path. So there are two paths. Those two paths gain is nothing but mk. Delta k is what? Delta k is 1 minus loop gains which are not touching the kth forward path. Delta k is nothing but the loop gains which does not touch this kth forward path. Okay, now those are nothing but, that is nothing but delta k. Delta k is nothing but, you should take 1 minus the loop gains which are not touching the forward path, what we have considered. Then delta is nothing but 1 minus sum of all the individual loops, whichever loops are there, no, those individual loop gains plus sum of 2 non-touching loops plus sum of 3 non-touching loops, so on. Non-touching loops means what? There should not be a common node between it, as I explained previously. Sum of 2 non-touching loops which should not be touching and 3 non-touching and so on, 3, 4, 5 and so on. First 1 minus sum of individual loop gains, then sum of 2 non-touching loops, like that you should take. After that you should substitute these all things in the transfer function, the Masson gains formula, to get the transfer function. That's it. We will see the sums, then you will understand. You will see one of the example, then you will understand how exactly the construction of signal flow graph from the signal flow graph and how to get the Masson gain formula. Use of Masson gain formula for finding overall gain of the signal flow graph. If you see here, there are two forward paths. One is what? x1, x2, x3, x4, x5. See, x1, x2, x3, x4, x5. This is one. I'll take one more color and indicate for you the second path. Second path is what? x1. For this, what is the gain? We will see first. x1, x2, x3, x4, x5. What is there? The gains, what it is? a1, a2, a3, 4 and a4, 5. These are the gains. So you will multiply those all gains in that forward path. That is nothing but first M1. Then we will take the next path. Next path is X1, X2, X3, X5. Next forward path is what? X1, X2, X4. Sorry, this is not forward path. See, this is why I am telling this is not forward path. Here, all arrows should be in the front direction. That is from input to output. So it should not be in feedback. Now what I have considered, their A42 is in opposite. So next forward path is X1, X2 and X1, X2, X1, X2, X3 and X5. This is next forward path. The green color line is the M2. M2 is what gains? A12, A23, A35. A35 are the gains. I hope you understood. Once again, I will clearly explain. Listen it. See, first forward path is X1, X2, X3, X4, X5. Straight line. All arrows are front direction only. That respect to gains is what? A12, A23, A34, A45. So you will write that as M1. Product of all the gains in the kth forward path. The kth forward path is first forward path, that is M1. Second forward path is, you have is here from X1 to X2 to X3, again from X3 to X5. You have another forward path. If you see, this is in forward direction, this is also is in forward direction. What are the gains? A12, A23 and A35. A35. So like this, that is M2. Like this you are going to write the forward paths M1 and M2. If you see here, again it is mentioned, whatever I have shown in this diagram, no, that is what is here. This one path, this one path. Okay. Then after writing that, what we should say is, second step is, we should find the individual loops what are present. What are the individual loops present? First we have seen the forward path. Now we will see number of loops present. The individual loops present here are what? First loop L12 is, this is one loop, no? X2, X3, X2, X3, X4, X2. That is L3 it is actually. This is L3. First loop we will write this, or else we will write this as first loop. Here this X2, X3. This is one loop. X2, X3 and X2. This is one loop, no? Forward and backward. So X2, X3 is first loop. You will get A23 and A32 as the gain. We need to multiply these two, A23 and A32. Then the second loop what we have? X2, X2. We'll go from left to right. By mistake I have gone to this, but we'll go from left to right. How many loops are there? Next loop what you have? The X2 you have X2 and X2 self loop. A22 is the gain, loop gain. Then L3 is what? From X2, X2, X3, X4 and X2. X3, X2, X3, X4, X2. What are its gains? A23, A34 and A42. Then X44. There is one more loop at X4. So A44 is the next loop gain. Then you have from here, if you see X2, X3, X4, X5. Again another loop is there here. So this is another loop. The gains are A23, A34, A45 and A52. Then next loop you have is, if you see clearly, X2, X3, you have to X5 and back to X2. Okay, this is one more loop. Forward and backward it should go. It should go in forward, and in the same arrow mark direction they should be backward. So that is nothing but a loop, no? So gains are what? A23, A35 and A52. So we have written the, what are the M1 and M2, the main forward paths. Then we have written all the loops which are present. Now what we should do is, after writing, we should write, there are three possible combinations of two non-touching loops. Two non-touching loops are there. Which are those two non-touching loops which doesn't have the common node? Is L14, nothing but x2, x3, x2, x2, x3, x2, one loop, x2, x3, x2, one loop, and x4, x4. These two are non-touching loops, right? You can write this as this is L1 and this is L4. So L14 is A23, A32, A44. You will multiply these gains A23, A32, A44. Then next non-touching loop is what? X2, X2, and if you see this loop and this loop are also not touching, no common node. Again you can multiply A22 into A44. Again another loop is what? This loop is also not touching, right? Not touching loops. So you will multiply A23, A35, A52 and A44. If you see the touching loops, what are there? So we have not considered. This loop is touching to this loop, so we have not considered this. Again this loop is touching here, this loop is touch, like that. So which is not touching to each other, that loops we need to consider. We have considered there are three combinations we have to, okay, three non-touching loops we have got. Then there are no combinations of three non-touching loops. There are no three non-touching loops which are present at a time. No combination of three non-touching loops, but no four non-touching loops. So we can directly write the delta. The delta is what? 1 minus what we will write first? All the loop gains, what we got, sum of loop gains, then the two non-touching loops present. The two non-touching loops what we got, three loops we got, that we will add. We got delta now. After finding delta, the first forward path is touching all the loops. If you see this loop, this first forwarding path, no, for this all the loops are touching. Am I right? All the loops are touching to this line. So delta 1 will be 1. The second forward path is not touching one loop. If you see the second forward path is what? This is the second forwarding path. For this, which loop is not touching? This loop is not touching. So A44 will be the gain. So delta 2 will become what? So for that what we should do? Delta 2 for M2 will become what? The non-touching loop to the M2 is 1 minus, we should do 1 minus A44. Non-touching loop is A44. So 1 minus A44. Now add, what all you got, you put it in the formula. M1 you know, M2 you know, delta 1 you know, delta 2 you know, M1 is this, M2 is this. For M2 what is not touching loop? A44, so 1 minus A44, the delta you know, you put the delta. That is nothing but a delta function. Done. This is what how we will calculate from this signal flow graph the Nash and Gaines formula. Basic properties of signal flow graph. What are the basic properties of signal flow graph? Signal flow graph applies only to linear system. The equations for which a signal flow graph is drawn must be algebraic equations in the form of cause and effect. It should be in the algebraic equation. Nodes are used to represent variables. Yes, nodes are used to represent the variables. Normally the nodes are arranged from left to right, from input to output. We need to arrange from left to right. Signals travel along branches only in the direction described by the arrows of the branches. Signal will travel only in direction based on the arrows what we mentioned. So arrows are very important. Don't miss writing arrows. And the dots or the nodes we need to mention. The branch directing from node kx to node xk to xj represents the dependence of xj upon xk, but not the reverse. Okay, a signal xk traveling along a branch between xk and xj is multiplied the gain of the branch akj, so that the signal akj xk is delivered at xj. See, we multiply the gain, no? So from this node to this node we multiply the gain, because the whatever is there here, it is going to be sending to this node. So that is why we multiply. For a given system, a signal flow graph is not unique. Signal flow graph will be not unique for any of the given system. It's not unique. Many different signal flow graphs can be drawn for a given system by writing a system equations differently. A signal flow graph is not unique. It can be any type of signal flow graph can be written. Why the equations If the equations change, the signal flow graph change. Next we will see signal flow graph algebra. What is signal flow graph algebra means? There are some rules. Okay, based on the properties of signal flow graph, we can outline the following manipulation rules in algebra. If you see, the values of the variable represented by a node is equal to sum of all the signals entering the node. For the signal flow graph, the value y1 is equal to the sum of signals transmitted through all incoming branches. Y1 is equal to what are the incoming branches? This is one incoming, this is incoming, this is incoming, then this is also incoming. So you can write A21 y2, A31 y3, A41 y4, A51 y5. These all are incoming nodes. The value of variable represented by a node is transmitted to all branches leaving node. So incoming nodes will go to the leaving nodes. What are the leaving nodes present? Leaving nodes present are this, this, this. So the leaving nodes will be A16 y1, y6 is equals to A16 y1, y7 is equals to A17 y1, y8 will be equals to A18 y1. So this will be the input node, no? So this will be the input node. Incoming nodes will be y1 will be equals to, outgoing nodes will be y6 will be equals to y1 into that respective gain. Understanding? Then parallel branches in the same direction connecting two nodes can be replaced by a single branch which gains equal to the sum of gains of the parallel branches. An example that is illustrated is here. See, parallel branches can be, this is one, arrow mark is going in this way, arrow mark is going in this way. Here, if you see in this way, and this way, okay. We can write a plus b plus c. Why? Because this from y1 to y2, which all are going a, b, c. They are in parallel. So a plus b plus b can be written. Parallel branches in the same direction. If they are in the same direction, keep that in mind. These, you know that these three are in parallel branches, but they should be in the same direction. They are going from left to right, left to right, left to right. Then what can be? It can be replaced by a single branch like this, equal to sum of gains of the parallel branch. That is nothing but a plus b plus c. Understanding? Then a series connection of unidirectional branches as shown in figure 3.12 can be replaced by a single branch with gain equal to product of the branch gains. See, a series connection in this way, which is going forward direction, can be replaced by the gain y1 to y4, a1 to a23, a34. What we have seen in the forward path, we have multiplied all the gains, no, like that. Then final rule, nothing but a single feedback loop can be replaced by single branch with gain as shown in figure. See, there is a forward path like this and a feedback loop like this. So we can write this. If you see, this looks same like a block diagram. G backward path, here minus is present and here H is given. Okay, then what will write? G by 1 plus G into H. The same way, here it is going and going back to feedback. So G of S by 1 plus G of S into H of S we can write. Why? Because here minus is the feedback, so plus you will write here. Same way, like a block diagram, we will write for the signal flow also this formula. Construction of signal flow graph for control systems. Final topic, that is the following procedure can be followed to convert a block diagram into signal flow. If there is a block diagram given, you need to convert into signal flow graph, then find the transfer function. How to do that? There is some procedure, 5 points you need to keep in mind. In the given block diagram, assume the nodes as input output. The nodes will be inputs and outputs. Okay, the nodes at input and output. Assume nodes at the input and output initially at every summing point, at every branch point. At every summing point you should consider a node, at every branch point, and in between cascade blocks. In between the cascade blocks is nothing but, if for example there is a block like this and there is a block like this, in between this block also we need to consider a point. Why? Because there will be output coming here, again going input. So we should consider a node here. Okay. In case of signal flow graph, where all we should consider nodes, input and output you should consider the nodes at compulsorily, and for every summing point and at every branch point and between the cascade blocks. Draw the nodes separately as big thick dots and numbers dots in 1, 2, 3 like x1, x2, x3 or 1, 2, 3, 4 you can write. From the block diagram, find the gain between the nodes in the main forward path and connect all the corresponding nodes by directing straight line segments marking the gain between the nodes. Same like block diagram, how the direction goes in the block diagram. No? In the same way, in signal flow graph, you need to mention the directions and write the respective gain upon the direction mentioned. Okay. Draw the feed forward paths between various nodes and mark the gain between nodes on different branches. Draw the feed forward paths need to be drawn between various nodes and mark the gain between nodes on the different branches also. Draw the feedback path. The feedback paths also need to be drawn in the opposite direction in this way. Opposite direction if this is one node and this is one node, and mark the gain of the feedback paths like minus h2, minus h3, what we have seen previously in example. Like that, we need to convert all the things into signal flow graph, and using mass and gain formula we can find the transfer function. We will see now sums, you will get a good clarity. Comparison of block diagram and signal flow graph. We will see the comparison of the block diagram and signal flow graph. It is a pictorial representation of functions by each component and of the flow of signals. It is a graphical representation. It can be used to represent linear as well as non-linear. It is only for linear. No direct formula is available. Here direct formula, mass and gain formula is available. Step-by-step procedure is to be followed for the finding transfer function. It can be obtained in just one step. For finding the loops and all, we can do directly by one step. It is not a systematic method. It is a systematic method. It indicates more realistically the signal flows for the system than the original system itself. It is constrained by more rigid mathematical rules than block diagram. Here only block diagrams are there. Here using the mathematical expression we will find. Then for a given system, the block diagram is not unique. Many dissimilar and unrelated systems can be represented with the same block diagram. Yeah, for a given system, the signal flow graph is not unique. Okay, same. Here it is not unique. Just we compared both how we got block diagram and signal flow graph. Just to understand, I have put this also. You see the example. See, this sum I have done by block diagram reduction method also in the previous video for block diagram reduction. Now we will see the same diagram, same block diagram to convert into the signal flow graph and finding the transfer function. How to do? First, what they told, input and output needs to be considered as nodes. So R input and C output. We have shown the arrow mark. Okay. So this summing point needs to be considered as first point, and the next between these two cascade points also cascade points, or it is a branching point also, another branch is opening, so we'll consider as x2. Then next you have a summing point, you'll consider as this summing point, and this final x4, and this is the output point C also needs to be considered. After considering, if you see, first the input to x1 there is anything? No. From x1, this is x1, no, this summing point. So from there what is connected? See, there what is connected? Minus G4. From this point to which point? Here x6 also it is connected. Why? Because here one more summing point is there. So you will take x6 also here. So this will be x6. So in the forward direction only it is mentioned. So in the forward direction you will take minus G4. Why? Because here minus is there. So you will take minus G4. After writing this, there is one more thing connected to this, that is in ulta direction. In ulta, that is here also minus is there. So minus H2 will be the feedback to this x2. This is x1, this is x2. So this x2 we will consider. After considering till h2, again what we will do, from x2 to x3 there is a G1. This is x2, this is x3, so this is G1 between. Okay, from this X3 there is one more G3 with minus sign, and this is X4. X4 to final point there is 1 as a gain, there is no gain, so it is mentioned as 1. This X5 point is connected to H1 to this X6 point, so plus H1. So we are now done with the block diagram to signal flow graph conversion. What we did here, summing points, input nodes, all are considered into nodes and connect accordingly how the block diagram is connected. From here, first we should find what, according to the Masson gain formula method, signal flow graph method, we should find how many forward paths are present. If you see, there is one forward path in this way, there is one more forward path in this way, see one more forward path, and one more forward path is also present. I'll take green color for this. One more forward path is in this way, in this and this way, if you see, right? And one more forward path is also present, that I will mention with yellow. See, from here, here, here and here and here. See, understanding? So there are different forward paths. From output to input, there should be in the same direction when you are considering forward path. Keep that in mind. See, these all are from left to right, right? Here when we consider this also, from left to right direction only arrows are there. When we consider this also, from left to right only it is there. Left to right, again in this direction, left to right. In the same path the direction should go of different paths. So 4 paths are there. Then respective gains need to be multiplied. For M1, what is the gain? For M1, what is the gain? 1 into 1 into G1 into G2 into 1. So G1, G2 is that respective delta 1. Is there any of the loop which is not touching that line? No, all lines, all loops are touching. So delta 1 will be 1. For the next forward path, what is the gain? G1 minus G1, G3 minus G1, G3. So all the loops again touching to this forward path also. So delta 2 also will be 1. Then third forward path. Then third forward path is that gain is minus G1, G2, G4, H2 will be the next. So delta 3 will be also 1. Why? Because for this path also the loops are touching. Okay, there should be loops which is not touching that path. So then only we should do 1 minus that respective gain path. But here no touching loops, so 1. When fourth forward path also you have minus G1, G3, G4, H2 and delta 4 will be 1. Why? Because all the loops are touching to that forward path. Now we are done with M1, M2, M3, M4, delta 1, delta 2, delta 3, delta 4. Now we should do for delta. For delta what we should do? We should consider all the loops. How many loops are present? There are 2 loops present. Okay. One loop is, this is one loop and this is one more loop. Loop means we should start from one point and end at the same point. So 2 loops gains can be multiplied. For first loop what it is? G1, G2, H1 minus H2. So minus G1, G2, H1, H2. L2 is G1, G3, H1, H2. Here as minus minus, both as minus minus, it will become plus. Now we are done with L1 and L2. Is there any non-touching loops? 2 non-touching loops, 3 non-touching loops? No, all the loops are touching. So the determinant of the signal flow graph is delta is equals to 1 minus the L1 plus L2. If there is non-touching loops, then plus delta plus L1 like L1, 2, L2, 3 like that, which are non-touching, we can write. But there is no non-touching loops present. So only the all loops addition by 1 minus we can do. Delta you got. You know M1 delta 1, M2 delta 2, M3 delta 3. All you will just put it into the equation, you will get a transfer function. So simple, no? Next. Obtain the transfer function of the control system whose block diagrams shown in figure by signal flow graph method. Again you convert into signal flow graph. If you see, this is R point, this is X1, this is X1, this is X2, this is X3, and this is x4, and this is x5, this is x6 and x6, and this is x7. This is also known. Understanding? So now what we should do? You'll mention R and C also. From R to x1, there are any gains or something? No, 1 you will take. From x1 to x2, there is any gain? No, 1 you will take. Then x2 to x3, there is g1 as the gain, g1. Then x3 to x4, x3 to x4, there is nothing, 1. Then x4 to x5, g2 is the gain. So g2 you will take. x5 to x6, g3 is the gain. x6 to x7, 1 is the gain. Then you will see the feedbacks and forward part, what are there. Then g4 is there. So x4 to x6. So x4 to x6, g4 you will mention. Then from x7 point, there are two things going. One is to x3, that is minus h2. Why? Because minus is present here. And one more is minus 1, that is from here to x1. From here to x1. Then one more thing is from x5 to x2, that is minus again. So x5 to x2 minus h1. Understood? Now you will written the what? The signal flow graph. After writing signal flow graph, what you are left with? We should write the forward paths. How many forward paths are present? If you see here, there is one straight forward path present, and one more forward path is also there. This is one more forward path. There are no other forward paths. See, these are the feedback paths, feedback and feedback. Back they are going. Forward there are no forward paths. So this will be M1, this will be M2. M1 is what? G1, G2, G3. There is gain G1, G2, G3. Then M2 is what? G1, G4. G1, G4. With this respective, with the first signal, is there any loop which is not touching it? No, all are touching. With the second path, all are touching. So delta 1 and delta 2 will be 1 itself. Now we will write the separate loops which are present. How many loops are present? We will see. How many loops are present? Total 5 loops are present. This is one loop. This is one loop. Write them and practice, then only you will understand. But because in the same slide I can't put all the things, no. So I am doing in the second slide. So you should draw with me so that you will understand. These are the loops. So that respective gains need to be multiplied. You will get the respective gains L1 to L5. After that what we will do? Delta is equals to 1 minus, as there are no two non-touching loops. All loops are touching to each other. There is some common node between all loops. There are no two non-touching loops. So then the formula for delta will be 1 minus L1 plus L2 plus L3 plus L4 plus L5. You will write that delta. You know M1 delta 1, M2 delta 1. Mention, write them all and put them into the formula. Then you will get the transfer function which is mentioned here. Okay. Next question. Obtain the transfer function of the control system whose block diagram shown in figure by signal flow graph method. Again, what we should do? First we should write the signal flow graph. How to write? This R you will take as input, output here C as point. Then this will be the first point, this will be the second point, this will be the x3, and this will be the x4, this will be the x5, and this will be the x6. This will be the x5, this will be the x6, and this will be the x7. And the final point is C. Okay. If you see from R to 1 there is something? No. So 1 is the gain. Then from x1 to x2, g1 is the gain. x2 to x3 again 1. x3 to x4 there is again 1. x4 to x5 there is g2. You will mention g2. x5 to x6 1. x6 to x7 g3 again. Now we will see the other things. G4 is mentioned between x4 and x5. Okay. Then other things what? From x7 to reference input, what all you have? There is minus 1 present, x1 to x7, x7 to x1. Then from x7 to x3, there is minus h3. Why? Because here it is minus. Again from x5 to x2, x5 to x2 minus h2. Now we are done with the signal flow graph. Once you are done with the signal flow graph, it is very easy to do the things. How? First we'll write the forward path. First we'll find the forward path. How many forward paths are present? One thing is, so it is the single line, the straight line, that is forward path itself. And one more forward path you have, that is this forward path. These are not forward paths because they are backward paths. Forward paths only 2, so you'll write them both. After writing, you'll multiply G1, G2, G3 and G1, G3, G4. So 2 forward paths you got. Then you should find the other loop gains of the individual things. See, first L1 is, what is the first loop you have? L1. L1 is G2. First loop what you have? G2. From x2 it starts. It will start from x2, G2 in this way. There is one loop. Okay. Then from x3 you have one more loop. From x3, x4, x5, x6, x7 to x3 again. One more loop. You multiply them. Minus G2, G3, H3, minus G2, H2. Then one more you have x3, x4, x3, x4. I'll take one more color. x3, x4, x6, x6, then x7, then x3. That you are done. Then what you have? Next loop. Next loop you have x1, x2, x3, x4, x5, x6, x7. This is one more loop. Right, this is one more loop. If you see correctly, this looks like one more loop. This is one more loop. So x1 is the starting point, x1 is the starting point, in between one loop. Again you have one more loop, x1, x2, x3, x4, x4 and x6, x7. Same. This is one loop and you have one more loop as, in this way you have one more loop. x1, x2, x3, x4, x5, x6, x7. This one. See, I'll mention with the line which is mentioned. See, red color is this. Blue color is this. Blue color is x1, x2, x3, x4, x5, x6, x7, x1. And red color is x1, x2, x3, x4, x6, x7, x1. Respective gains you will multiply. The path what you take, no, whichever gains are present in that path gains you will multiply. Anyways, after writing that, the delta, if you see, no paths, loops are not touching. All loops are touching. Since all loops are touching, but for both forward paths, delta 1 and delta 2 will be 1. So the determinant of the signal flow graph delta is equals to 1 minus the all loops L1, L2, L3, L4 addition. You will get the delta. You know M1 delta 1, M2 delta 2. You will put all the values in the equation. You will get the final transfer function. Obtain the transfer function of the control system whose block diagram shown in figure by signal flow graph method. First what you will do? First you will make the points. First is, this is R anyways. Then you have 1, 2, this is 3, this is 4, this is 5 and this is 6. Okay. From R to 1, 1, 1 to 2, 1 is again, 2 to 3, x2 to x3, G1, x3 to x4, G2, x4 to x5, G3, x5 to x6, 1, x6 to the C point, it is 1. Okay. Then H2 is going feedback from x5 to x3, x5 to x3 minus H2. Why? Because minus is given. Then from x4 to going to x3 and x2 also. From x4 to x3, from x4 to x3 and x4 to x2 is also going. You can mention that way, and that is nothing but H1 is going to x3 minus h1, and from x1 to x2 it is going only 1. Nothing but there is no gain, no feedback present, so 1 will be the feedback. As it is plus, you take plus 1. Then from x6 to x1 it is g4. Sorry, it is not from x6 to x4, it is x1 to x6, forward path. So x4. Nothing but g4 will be the, why? Because here it is in this direction it is mentioned. So we will take from x1 to x6. Now we are done with the signal flow graph. What we should do now? Forward path. One forward path is the straight forward path, and one more forward path you can see here. Here it is backward, backward, backward. One more forward path is this. So this will be the one more forward path. Now we will see which are the M1 and M2. These are M1 and M2. You got G1, G2, G3, G1, G2, G3, and one more is G4 is the forward path. For this, delta 1 will be delta. As you know that it is delta 1 equals to delta. Why? Because no, in this forward path, all loops are touching to this forward path. So delta 1 will be 1. For the forward path 2, if you see, no loops are touching. See, this is the forward path what we took, no, from here. See, this loop is not touching, this loop is not touching, or whichever loops are present in the question, no loops are touching. So then delta 2 will become what? Delta itself, no. Delta what we find? 1 minus the number of sum of loops, and then plus non-touching loops, like that we will find. So as there are no paths which are touching to this, they all are not touching loops, then delta 2 will become delta. Keep this in mind. Then loop, there are 3 loops. This is one loop, this is one more loop, and this is one more loop. Those all you will multiply anyways. Minus G2, G3, H2, minus G2, H1, G1, G2, H1. With minus signs you need to take. Loops not touching the second forward path. See, these all are not touching, as I told. So the determinant of the signal flow graph will be delta is equals to 1 minus L1 plus L2 plus L3. Right? See, there are no 2 non-touching paths or 3 non-touching paths. So L1, L2, L3. So 1 minus this delta, 1 minus this is the delta. You know M1 delta 1, M2 delta 2, and delta you will just substitute and you will get the transfer function. See, why here delta 2 is called delta? Because anyway which are not touching to this forward path, what we will do, will minus that. In these all are nothing but not touching. L1, L2 are not touching to this forward path. So we are taking this delta only as delta 2. Okay. A system is described by the following set of linear algebraic equations. Draw the signal flow graph. See, they have given the equations. We should draw the signal flow graph from that equations. How to draw? See, first you will, if you see the highest point is x5 is the highest point. I can see 5th point is the highest point. So till x5 you will take x1, then you will take x2, x3, x4, x5 continuously till x5. You have see, if you see here, x2 is connected with what all is a1 to, see, from x1 to x2 there is a1 to, okay, a1 to x1, nothing but. Then for x2 there is a self loop a1, a2 to, okay, then you have that is a3 to x3, a32. A32 means what? From 3 it is starting and it is ending at 2. So a32 in the backward direction, x3. Okay. Then x3 is equals to a23 x2. From a2 it is starting from till it is ending till x3. So a23 will have the gain till x2. Then you have a43 x4. It is starting from x4 and ending at 3. A43 nothing but x4. Then if you see, x4 is equals to a24. A2 to A4. From A2 to A4 forward direction it is. Okay, then it is x2, a24 x2. From x2 it is starting. Why? Because see which number is starting. No, based on that you should understand it is forward or backward. If it is a43, it is backward. Why? Because first the highest number is taking back to front. So minus you will take. Minus or the backward path you will give. Understanding? Backward path. But here it is a24. So from 2 to 4 it is going. So a24 here going. Then a34. From a3 to a4. a34. This is the gain a34 between third point and fourth point. a44. It is at the self loop. Then you have x5. x5 is nothing but a25. 2 to 5 there is a gain. a25 is the gain. a25 is the gain. Then I think this is missing here. a25 is the gain. Going to 2 to 5th point. Then 4 to 5th point, what is going? 4 to 5th point. a45 is going. So a45 will be the gain. Now we are done with the signal flow graph. Now what we will do? The forward paths and the gains associated with them are, how many forward paths are there? See, if you see, this is one forward path and this is, I will mention with the other color, this is one more forward path. Okay, right, a12, a24, a45. Another forward path is a12, a25. This is one more forward path. See, red is M1, yellow is M2, blue is M3. So now we are done. Now we should see which loops are not touching to those paths. If you see for the first path, all loops are touching, so delta 1 will be 1. For delta 2 also, if you see, all loops are touching. In some or the other way, here this loop is touching, this loop is touching to this loop is touching to this. So all loops are touching. In delta 3, if you see the M3 path, if you can see, this loop is touching anyway, this loop is touching. And if you see, this one loop is not touching. One loop is not touching. What is that loop? No, two loops are not touching. What are those loops? A44 loop, A44 loop and A34 and A43 loop. So you can write them 1 minus that loops. That will be the delta 3. Not touching loops of that respect to forward path. Now we will write the loops for all the equations. L1 will be A22, L2 will be what? A23 and A32, and one more you have is A34 and A43, and A44 you have. Then one more loop you have is what? A24, A24, A43, A24, A43 and A32. A32. I'll mention that. I'll draw that and show for you. See, A34, A43, A32. This is also, sorry, not this. A34, A43, A32. This is one more loop. Right? Same direction it is going. Loop is going in the same direction. It can't be different direction. No, you multiply. Now we are having those all. Now you need to find non-touching loops. Non-touching loops. There are some non-touching loops. That is, if you see L1 and L4, L14, A22, A44. One more non-touching loop. What you will see? L1 and L3. That is nothing but A22. This A22 and A34, A43. These two. You can multiply them to. Then A to A44. This is not touching to this. Right? A23, A32 and A44. So all non-touching loops you can multiply. That will become that respect to See, you have not already written L1, L2, L3. No, based on that you should see which loops are not touching. Like that. For example, L1 and L3 are not touching, so it is called L13. L1, L4 are not touching, so L14. L2, L4 are not touching, so L24. Like that it is. So delta is what? Equals to 1 minus L1 plus L2 plus L3, that is all sum of the all loop gains plus non-touching loops. You will add, then you will get the delta. You know M1 delta 1, M2 delta 2, M3 delta 3. After getting delta also, you know, you will substitute, you will get the transfer function. Apply the gain formula to the signal flow graph. See, they have already given the signal flow graph. You will find the gain formula. You will apply the gain formula to find the transfer function. The forward paths present. What are the forward paths? This is the first forward path. There is one more forward path present. If you can see, this is one more forward path. Right. First forward path G1, G2, G3. G1, G2, G3. Second forward path G4 and G3. So there are any loops which are not touching to those forward paths. If this is the first forward path, the red color line, what you can see there are all loops touching. For the blue color line also all loops are touching. So delta 1 and delta 2 will be 1. After that the loops, all the loops we should consider. First loop will be what? First loop will be what? G1 minus H1. This is one loop, first loop. G3 minus H2. Second loop. Third loop you have is G1, G2, G3, G1, G2, G3 minus H3. This is third loop. And you have G4, G3 minus G4, G3 minus H3, one more loop. You have H4 as one more loop. Understanding? Like this you should see the loops which are there. All the loops you got. Anyway, delta 1, delta 2 are 1, 1. Are there any non-touching loops? Yes, there is there. If you see L1 and what is this? L3, I think. L1 and L2 are not touching. So L1 and L2 are not touching. These two are not touching. So what are those? Minus G1, H1 minus G3, H2. You need to multiply. You will get G1, G3, H1, H2. Then L1 and L5 are not touching. This L1 and L5 are not touching. This is L1. This is L5. They are not touching, no. So they are nothing but G1, H1, H2. You need to consider all the non-touching loops, okay? After finding, you will write the delta formula. You will get the delta. Substitute all the things. You will get the transfer function. Next question. Same way they have given the signal flow graph. First, we will find the forward paths. What are the forward paths? One signal straight line is one forward path. One more forward path is G6. So, with any loops which are not touching to the forward paths? No. Yeah, see, there are some loops which are not touching to G6. What are those? We will see at the end. First, we will write the M1 and M2. Then, which all the loops are present. All the loops you will write whichever are present. There it is mentioned anyway. You can check it out. I am going a little bit fast now. Why? Because almost 5 to 6 sums I have done slowly. After writing, what you will do? The non-touching loops you should find. The non-touching loops in the whole all loops. There are two non-touching loops, L13 and L35. Then you will find the delta. Delta 1 will be 1 by because of the first forward path all the loops are touching, and for the second forward path, for this forward path, if you can see, there are some loops which are not touching. What are those loops? This is not touching, this is not touching, this is some two loops are not touching. That is the G3H2 and G4H3 are not touching. Right? Again, this is touching. So these are the loops which are not touching to the second forward path. So you will take 1 minus that respect to non-touching loops to that forward path. Then you'll mention the gains formula, substitute all the values which you got, you'll get a transfer function. So I have given some two practice questions. Please try them. I have given the answer also to just you can verify them. Okay. By this we successfully completed module 3. See, we have seen the introduction, types of control system, effects, modeling of mechanical system, electrical, analogous. Again, after these concepts, two separate videos have done for the mechanical translational and rotational problems. And I have done separately for block diagrams one video, and now in this video I completed signal flow graphs. So you successfully completed the module 3. So module 3, all these modules which I am covering in this subject, you need to write and practice. I am telling in this almost in all the videos, writing and practicing is very important. Why? Because you need to solve the problems. Why? Because your brain should work, then only you can solve them. To solve them you need pen and paper. So try to solve them, then only you will understand. So I hope you are understanding my concepts, whatever I am telling from module 1 to module 3. If you really are liking the way I am teaching, so please understand them and gain knowledge. If you have any doubt, you can please comment in the comment section. So I will check and redo that topic, or I'll do as a revision later. If you really want to do that, you just mention that in the comment box. So by this module 3 is done. See, these sums only will come, I can't say. These are the concept I'm going to tell you. Using these concepts, they can ask any of the question. So you should know the concept and how to solve. So only I'm telling use pen and paper. So I'm stopping the video here. I will start the new module, module 4, and I will come back. So by this, I'm stopping this video. Thank you. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.